Welcome back. In this module, we're going to study sum, product, and composite functions. Applying the familiar operations of addition, subtraction, multiplication, and division on the basic elementary functions we revised in the previous module, countless new functions can be created. For instance, we can add and multiply the basic exponential, sinusoidal, and parabolic functions in a variety of ways to create new functions. Moreover, applying the operation of division on the basic trigonometric functions sin x and cosine x, all the other trigonometric functions can be defined. Applying the operations of addition and multiplication on the set of simple polynomials 1, x, x squared, x cubed, and so on, we can create what is called the general polynomial. The highest power of x is called the degree of the polynomial. In this context, linear functions are degree 1 polynomials, and quadratic functions are degree 2 polynomials. Ratios of polynomial functions, such as the following, are called rational functions. Such functions always have domain all real numbers, except the values of x, which make the denominator 0. Besides the operations of addition, subtraction, multiplication, and division, another way to create a new function from two existing ones is through the operation of composition. For instance, define two functions, g and f, to be the natural logarithm and square root functions, respectively. A new function can be created from these existing two by setting the output of g to be the input of f, giving rise to the function f of g of x, which is the square root of ln x. Terminology-wise, this new function is called f composed with g, and these types of functions are called composite functions. Since the function g is nested within the function f, the function g is referred to as the inside function, and f is called the outside function. You must be very careful when working out the domain of a composite function. Specifically, the function f composed with g exists only for those values of g which fall inside the domain of f. This gives rise to two situations. The first of which is when the values of the inside function g always fall inside the domain of the outside function f. In other words, the range of g is a subset of f's domain, so that for all x in g's domain, g of x is a valid input for f. Then the domain of f composed with g will just be the natural domain of the inside function g. The second situation is when there exists values of g of x that are not inside the domain of f, so that the domain of f composed with g will not be the natural domain of g, but a subset. Let's look at an example of the first situation. Consider the following composite function. The range of the inside function g is the set of all positive numbers greater than and including 3, which forms the subset of the outside function's domain. Therefore, the domain of f composed with g will just be g's natural domain, the set of all real numbers R. Let's now look at an example of the second situation. Consider the following composite function, the square root of ln x. Here, in contrast to the previous example, the range of the inside function g is the set of all real numbers, which is certainly not a subset of the outside function's domain. Indeed, for any choice of x between 0 and 1, not including 1 itself, the inside function ln x will be a negative number, which is not inside the domain of the square root function f. Therefore, these choices of x do not form a part of the composite functions domain. Let's now move on to range. Two situations typically occur when trying to work out the range of a composite function f composed with g. The first of which is when every element in f's domain is some output of g. In other words, the domain of f is a subset of g's range, so that every possible value of f is realized. Then the range of f composed with g will simply be the range of f itself. The second situation is when there exists elements of f's domain that are not outputs of g, so that the range of f composed with g will not be the entire range of f, but a subset. Let's look at an example of the first situation. Recall our earlier composite function, the square root of ln x. The domain of the outside function f is the set of all positive numbers, including 0, which forms a subset of the inside function's range. Therefore, every possible value of f is realized, and so the range of f composed with g is simply the range of f itself, which is the set of all positive numbers, including 0. Let's now look at an example of the second situation. Consider the composite function e to the power of 2 cos x. Here, in contrast to the previous example, the domain of the outside function f is the set of all real numbers, which is certainly not a subset of the inside function's range. Indeed, since the range of g is the small interval of real numbers from -2 to +2, the range of f composed with g will be the range of f on this restricted domain only. Alright, it's time to pause the module and have a go at the following practice questions. And here are the answers to the practice questions.